Hi everyone, we are Team 1, Eco-Engineering Alliance. Our project solution is called Lawn Rovers. My name is Lima, along with
John Odell.
Blake Jones.
Laura Midgley.
As an introduction for this design presentation, we provide an overview of why this design was needed, who it serves, and how we intend to create value based on our research. After identifying the need for sustainable year-round lawn care, as outlined in the problem statement, we identified 3 categories of potential users: those that have difficulty maintaining their own lawn, those that are too busy, and those with no access to traditional lawn services. Our proposed solution is the Eco-Engineering Lawn Rover system of 4 robots, a semi to fully autonomous lawn care solution. In the next slide, I'll cover the proposed robots. During design development, each team member created a proposal for the 4 identified lawn care needs to be accomplished: mowing, growing, edging, and weeding. The 4 designs shown here are the results of team voting on each of the proposed designs using the following weighted criteria: accuracy, safety, sustainability, affordability, and simplicity. Each robot will be discussed further in the following slides. Mowbot cuts the lawn. It accomplishes this using 3 blades within a chassis on all-terrain wheels. All are powered by 3 DC motors and an actuator. This design uses 2 input sensors for operation: a distance and IR remote. For initial operation, the user controls the bot to simultaneously cut and create a map of the lawn to provide boundaries to the rest of the robots in the lawn care system. Next is Lee and her growth bot.
Thanks, Blake. This growth bot aerates, seeds, and fertilizes the lawn using the information from Mowbot. It has distance sensors, an actuator to control the punch aerator, and micro servos for rotating the dispensers, then followed by a rake at the back to agitate the grass. Now to Laura and her weed removal bot.
Thank you, Lee. The Econator is the weed removal robot that scans the lawn for weeds once given the command to begin. With the scanner on the bottom of the robot and a laser to burn those plants instead of harsh chemicals removing all those weeds from the lawn, we have a really safe robot. Don't fret, because we will not fire until all animals and humans are not in the area. Scanners help detect any additional objects detected in the lawn, and all that information will be sent back to the Rover team once plugged into the charging station. Sean is next with the EdgeBot 3000.
Thanks, Laura. I was in charge of developing the design of the EdgeBot 3000 based on our decision matrix results. The EdgeBot 3000 is a robot that has a specific function as part of the team of robots. Its primary objectives are to trim grass at the perimeter of the yard and create a clean-cut transition from the yard to a different surface such as concrete. For the robot collaboration, first the Mowbot is sent out by the operator to map the area in detail and mark any obstructions. This mapping data is uploaded to a central server. Other robots use this data along with GPS for navigation. Then the Mowbot also cuts the grass to specified height. It has sensors to detect anomalies such as children, pets, or unmapped objects. After completing its task, the Mowbot returns home and initiates a completion call to start the next robot. The EdgeBot 3000 then trims the boundary using map and GPS data. It aligns itself to cut a clean edge between surfaces like grass and concrete, and it uses safety sensors to stop for any anomalies. After trimming the perimeter and any internal structures, the EdgeBot initiates a completion call for the next bot. The next bot is the Econator. It follows, targeting weeds. It scans the area, positions itself over each weed, and uses a laser to eliminate it. The Econator has safety features like a shroud and weight sensors to ensure safe operation. Once all weeds are removed, it returns and initiates a completion call for the final robot. And lastly, the growth bot aerates, fertilizes, and seeds the lawn. It uses the map data to focus on specific spots and employs safety sensors to detect obstructions. The growth bot's aeration spikes poke holes, fertilize, and seeds are dispensed, and a rake agitates the grass, promoting a greener lawn.
Our current competitors include professional lawn care services, do-it-yourself, or employ your neighbor. Our solution can benefit most by offering automation, a flexible schedule, consistency, and it is also eco-friendly. Overall, a great return on investment. Lastly, Laura, to wrap it up.
Team Eco-Engineering Alliance did feel they captured the concerns from our customer base, which led to the design, development, and display of our concept presented, the Lawn Rovers. The increased curb appeal through the use of eco-friendly robotic lawn rovers would allow our customers to experience a rapid return on their investment and immediate use of the lawn without waiting on harsh chemicals to dissipate. The time spent performing lawn care maintenance could now be spent other ways our owners felt could improve their work-life balance positively. We hope you enjoyed our presentation.